Question show time. Your questions, my answers. As always, wherever you are on my channel, if a question pops in your brain, just type it into the comments of the video. I'll gather a bunch of them up and I will answer them here. All right, let's get into it. Nishe Shethra. Hey Fraser, love the videos. What are the chances that we have already contaminated Mars and other bodies with microbial life? It's almost 100% certain that we have sent microbial life to other worlds like Mars. Our bacteria gets everywhere, even though scientists do the best job that they can to remove all the excess bacteria off of a spacecraft, to clean them as carefully as they can. Some get through, and we know that bacteria can handle the journey in deep space and come back and be reawakened. So there is probably bacteria on the surface of Mars, on our spacecraft, but the conditions there are incredibly harsh, right? The atmosphere is really thin, it's made of carbon dioxide, there's tremendous amounts of radiation, it's incredibly cold. So that bacteria is probably hibernating. And the conditions that the spacecraft are at are dry and dusty, regolith, Martian regolith, and not the kind of place that a bacteria could survive for a long period of time. Now, if we had the kind of spacecraft that was, for example, drilling into some aquifer and maybe trying to sample some of the, like salty liquid that's beneath the surface, then you might get a situation where our bacteria could infect it and maybe grow and proliferate on the surface of Mars. But right now, scientists think that this probably hasn't happened. But as we get more aggressive in the search for life on Mars, and that means looking in the places where there's water on Mars, then the risk of contaminating Mars is going to get greater and greater. So I think right now, we probably haven't contaminated Mars, but we do have to be very careful as we move forward. Josh M. Why do scientists assume aliens will build a Dyson Sphere? I mean, the human population will probably plateau around 2100 and decline by 2200. With fusion power alone, we'd have enough energy even for 11 billion people. If you chart the amount of energy that human beings have used since 100,000 years ago until now, and you put it on a logarithmic graph, you will see or an exponential graph, anyway, you will see the amount of energy that we use increase year after year, decade after decade, whether the population grows, whether our technology changes, whether we come up with more efficiencies, new energy sources, it doesn't matter. We just want to use more energy. And if you take that graph and you just chart it out into the future, you can essentially calculate the day when we will be using the same amount of fuel or same amount of energy as sunlight that falls on the Earth. And eventually you'll chart out the time that we will use as much energy as is emitted by the sun. And eventually you can chart out the amount of energy that we will use that's emitted by all of the stars in the entire galaxy. Will we actually do that? We don't know, right? We don't know what the future holds, but if the past serves as any kind of prediction of the future, we will use more energy in the future. And we don't know what we're going to use it for. Maybe we'll use it for computers, maybe we'll use it for manufacturing, maybe we'll use it to grow really amazing biospheres. We don't know. We just know that in the past, we've always wanted to use more energy, and so in the future, we will always want to use more energy. A Dyson Sphere is just to say what kind of thing would capture all of the energy from a star. If you enclose the star in solar panels, you get all that energy. You get 100% of the energy that's coming out of the star, and then you can use it for whatever you want. We don't know, but just look at the graph into the past, into the future, and just assume that at some point this will happen. Dagar COH. Hey Fraser, for the possibility that my question just slipped through your net, I'll pose it again. There are objects in the solar system rotating in the wrong direction, like 2015 BZ509. Do we have the capability to get to one currently? Is there such a mission planned? So as you said, right, all of the objects, or almost all of the objects in the solar system are orbiting around the sun in the same direction, right? The Earth goes around, when you look at from the top, you can see all of the planets going in the same direction, and there are the occasional objects, Kuiper Belt objects, things like that, that are going in the opposite direction. And some strange event must have happened to them to put them into a different direction. You've also got some situations where, for example, in Jupiter, some of its moons go in the opposite direction. You've got situations like Triton, which goes around Neptune, that's going around in the opposite direction. So there is a bunch of situations where we can have things going in the wrong way. But to get to an object that is actually orbiting the sun in the opposite direction from the rest of the planets would be incredibly energy intensive. So imagine you've got an object that is going the same speed as the Earth is going around the sun, but it's going in the opposite direction, right? Well, the Earth is going 30 kilometers per second around the sun. So in order to get to that thing that's going in the opposite direction at, say, 30 kilometers per second, you have to change your velocity by 60 kilometers per second. And that is incredibly difficult, right? We don't have any way to do that. Now, you could use slingshot maneuvers. So you could do, for example, what the Parker Solar Probe is doing to get close to the sun, which I mentioned in a previous video, is the hardest place to get to in the solar system. You could use various gravitational slingshots to change your direction and use the gravity of that world to put yourself into a new trajectory, but it would take a lot of flybys. I don't know the exact number. So I think it is theoretically possible for us to chase down an object that is, and orbit an object that's moving in the opposite direction, but you don't need to chase it down. If you just want a close look, you can do a flyby, right? If you're driving down the highway and a car is coming in the opposite direction, you don't need to be going in the same direction as it to get a close look. You just fly past, take a bunch of pictures, and you just head off in your own direction. So I think that getting to orbit would be one of the greatest technical challenges we could do. Getting a flyby, much easier. Alec Gromlamond. Could you not link 5 type upgraded Hubbles to get the same images or even better? I don't know, just asking. So the question is, could you take 5 Hubble Space Telescopes and link them all together and produce better images than, say, James Webb or something like that? Now, if you just took 5 Hubble Space Telescopes and put them side by side, and then you would get the equivalent collecting power of the total surface area of all of those Hubbles. If each one is 2.6 meters times 5, like what's that, 13 meters, right? So that's a big amount of view. But the even cooler thing that you can do is you can do a practice a thing called interferometry, where you essentially combine the light from all of these different objects. And what it lets you do is act like you have a telescope that is much bigger, as big as the telescopes are apart. And so you could set up those 5 telescopes in some kind of pentagram, and then they would act like a telescope the size of the pentagram that they are mapping out. But you have to line up the wavelengths of those telescopes perfectly, like literally down to the individual wavelength. And if they're, visible light, they are 700 nanometers, right? These are very, very small wavelengths. So there was a telescope that was planned called the Terrestrial Planet Finder, and that's what it would do. It would be a bunch of telescopes flying in formation that would combine the light and act like a much bigger telescope and be able to observe the surfaces of other worlds, be able to observe the atmospheres of other worlds, and it was canceled. So any listeners from Astronomy Cast know that we just whine all the time about the loss of the Terrestrial Planet Finder, and I hope it comes back. So I think that 5 Hubble Space Telescopes not linked up would be amazing. 5 telescopes linked up together would be the most powerful instrument we could have at our disposal. But incredibly complicated, and that's what the problem with James Webb is. With James Webb, they've advanced a bunch of technologies, the sunshade, some of the instruments on board, the way it unfolds itself, and they had to come up with a bunch of technical challenges that made the telescope more expensive and more complicated. And if you tried to fly 5 Hubble Space Telescopes in formation to act like an interferometer, it would be a tremendously complicated challenge. But there are some of these telescopes in the works. There's the ground-based Very Large Telescope, which is 4 8.4 meter telescopes arranged in formation, and they act like one big telescope. So we kind of know how to do this technology, and it's getting better and better every year. And I wouldn't be surprised if at some point in the future you see these super powerful interferometers flying in space. I can't wait. Milad Barid. What would your eyes see if you were floating about 20,000 light years above the Milky Way galaxy? Are there illustrations and pictures of galaxies too artistically manipulated compared to reality? I've got some bad news for you. If you were floating 20,000 light years above the Milky Way looking face down on it, you would see, and if you were in, say, New York City, you wouldn't see anything. If you had a place that had nice dark skies, you would see the core of the Milky Way as a sort of bright, glowy object in the sky, and then you would see the spiral arms of the Milky Way as kind of what we see today when we look up and see the Milky Way in the sky. There would be sort of this big cloud in the sky, but you wouldn't make it out very well. It would only be if you used a camera. And the problem with our eyeballs, right, our meat cameras, is that they throw out all the photons every 30 seconds or so that they collect, while a camera can record images for minutes, hours, days, weeks, and gather up all that light and show these really sensitive pictures. So every beautiful photograph that you've seen of the Milky Way, of deep sky objects, looks that way because the camera recorded photons for a long period of time, and we just can't see it with our own eyes. If we could take a camera there, then it would be one of the most stunning pictures you can imagine, right? Incredibly detailed images of the galaxy and the spiral arms and the central core would be amazing. But with your own eyeballs, it would be kind of unimpressive. And we are embedded in the Milky Way right now. The Milky Way isn't 20,000 light years away from us. It is only, we're in the middle of it. And yet you really, when you look up into the sky, you just see this diffuse glow in the sky under really dark, if you're in a really dark area, you see something kind of impressive. And that's the best that we can do with our own eyeballs. I'm sorry. Jim Fogarty. If Project Starshot could be used to send probes to Alpha Centauri in just over 120 years, would it not be possible to use that technology now to send small probes to the outer solar system and Kuiper Belt? Shouldn't we do that first before sending probes interstellar? Yeah, I've mentioned this several times on a bunch of our broadcasts that this idea of Project Starshot, the idea of laser powering a probe to send it out into space, a way to let a probe move without having to carry fuel, would be a really important development for us to be able to do. And this idea of having infrastructure in the solar system where you have a bunch of these laser arrays which can accelerate or decelerate solar sails from location to location would be one of the most useful things. It would be as useful for our exploration of the solar system, our colonization, our gathering up the resources of the solar system as building, say, the highways in the United States was. It's this infrastructure that once you get it in place, you can then use it again and again and again. And so you can imagine high-powered lasers that are orbiting Mars and Jupiter, and they're in the asteroid belt, and they're close to the sun, and each one can be targeted on some solar sail spacecraft and accelerate it, and then another one can be used to decelerate it. And I think that we should be developing these technologies here in the solar system before we try to take them to, say, try and send a probe off to Alpha Centauri. And I'll bet we will. I'll bet we will have experienced 100 years of using laser sails here in the solar system before we even attempt to send one to another star system. Fission. What happened to your audio? Ever since you started posting again, it sounds slightly muffled. Yeah, I apologize for the last couple of episodes. We had some problems with our audio. We got a new microphone. I'm not wearing my lav anymore. We've got a shotgun microphone. It's a Rode NTG2, so it's like a higher end microphone. And the problem was the combination of that microphone and my audio recorder, the H4n, sucked. And we didn't know this. So we connected them together and it was terrible. And then the previous QA also sounded awful because because we lost the audio and then we had to use the audio from the camera, which is terrible. So now we have this really cool little interface made by Panasonic that fits into my Lumix GH5 and allows me to record audio directly into the camera. So we're trying to make our audio setup a lot simpler and something that we can then use to do more on the road kind of stuff, where we can just turn on the camera, turn on the audio, and just start recording things without having to set up the lav mic and have a separate recorder. So we are experimenting, and I apologize to bring you along for the ride. Eric 2000. Do you think sci-fi stories should always be realistic? It's good that there are sci-fi stories with consistent science, but what about sci-fi stories with things like magic, dragons, or other Clark tech and so on? I think science fiction is like regular fiction in that its job is to tell a fun story. And that is literally the beginning and the end of my feeling on science fiction and fantasy, right? I don't get enraged when they have warp drives or anti-gravity or all that, because it's just a story, right? Now, where I do get a little miffed is when they try to be realistic or they try to use some real scientific concept, but then they clearly didn't research it enough to use it properly. And so it's like someone saw some buzzword in a journal, uses the term, but didn't actually ask a scientist how it works. And so that does drive me a little crazy. But just in the larger case, no. Aliens, all of that. It's just a story. And I think that science fiction has gotten us inspired for a lot of the technology that we see today. We've gotten really enthusiastic about it thanks to some of the predictions and some of the ideas from science fiction. So science fiction doesn't always get it right. It mostly gets it wrong. But when it does get things right, or it inspires us to work on some of the things that science fiction has told us would be possible. So I think at the end of the day, I don't get that stressed out about it. If they pick us, if they use some scientific jargon, then they better be careful. But apart from that, and also it's kind of like if they're lazy, right? Like there's a thing they could do and it could be scientifically accurate or not scientifically accurate, and they didn't bother to make it just a little bit scientifically accurate. I would prefer if they did. And then, okay, maybe I do overthink this. The sweetest thing is when you get something like The Expanse, where they do take a scientifically accurate thing like the way motion would work in a space flight with Newtonian motion, and make the show more exciting, because that situation isn't like you're just flying in fighter jets in air, that you're actually flying in space, and objects in motion tend to stay in motion, and objects at rest, and when you change your velocity, then things fly around the spacecraft like projectiles. That's pretty cool. And so I think the best is when some writers learn something about science, they adapt that into their story, and it makes the story better. That's how I feel. The Theorist. They're all great ideas. Now, how do we get clean water to all the people on Earth and end debt slavery here on Earth? Let's try to stay grounded. I'm not sure why you came to a video about space and talking about sending probes to Alpha Centauri. Like, the video title told you what was going to be in the video, and was definitely not about how we can get clean water to everybody on Earth and end debt slavery. And I don't know why you watch these videos about this, about the future of space exploration. Like, there's some pretty cool videos about how to clean water and how to end the income imbalance. And I would recommend that you go and check those out. There's some great YouTubers. I'm sure people will suggest them in the comments. But I'm a real believer that just technology in general, and specifically the development of the technology for us to be able to go to space, is going to be one of the most important advances to making Earth a better place, right? Right now, we pollute our environment. We dig things out of the ground, and then we dump the garbage on the ground. We gobble up the water from our rivers, and then we pollute that water, and then we dump it back into our rivers. Why do we do that, right? Why don't we go to space, where you've got Kuiper Belt objects with more water than gigantic lakes, that you could use up all that water forever and not have to pollute the environment down here on Earth? You could do heavy manufacturing. You could generate power. You could do all that stuff from space. Single asteroids have more minerals in them, more metals in them than have ever been mined here on the planet. So Earth is the best place in the universe for life. And we are ruining it by trying to build our modern economy in the middle of all of this life on this planet. We don't know of any other place in the whole universe that's going to be as good as this place. So that is the reason why I'm such a big fan of space exploration. Let's get off this planet. Let's use the resources of space. We've got 14 billion light years in all directions to harvest resources from, and we've got one planet Earth right here that we should protect and make as the best place to live in the entire universe. So that's why we want to do it. Okay, those massive structures we decide to build in the future will probably be done with artificial superintelligence, construction drones, and robots. I think any direct role humans play in such construction will be very limited. I think you're mostly right. I think that the future of our colonization of space, the future of our utilization of the resources of space, is going to be mainly sending our robots into space to dismantle asteroids, to dismantle Kuiper Belt objects, to send, to harness power, to do manufacturing and all that kind of stuff, and to send the final goods and the rewards back down to Earth so that we can, as I mentioned before, make Earth a better place, have better lives. But I think there will also be some percentage of the population that's going to want to live in space, that we will eventually, thanks to our robots, build the kinds of interesting environments out in space that are as fun, as wonderful to live in as Earth. We're going to build gigantic, rotating space stations that people will live in and have the exact kind of climate that they want, harnessing energy directly from the sun, things like that. So I think that the robots are going to do the heavy lifting for most of what we do for the far future. And most people are going to probably want to still just live on Earth. And some fraction will eventually want to live in the solar system. And if we get our technology good enough that the solar system is livable enough, then more people will want to live in space. But you are one micrometeorite away from a very bad day when you're in space. Constant radiation that you need to protect yourself from. A lack of atmosphere. Terrible temperatures. Space is really bad right now for us. The very limits of what we can do. So I think we're going to want to live on Earth and let our robots do the heavy lifting for us. Uzi Mike. Such a worthless project. Even if you get all that hardware into space, there are so many things that could go wrong over so many years. What would it accomplish? Why not just spend the money and time on more powerful telescopes, because nobody will ever actually get there with Dragonfly technology. By the time it gets there, it will be so outdated anyway. Sounds like a bunch of middle school kids thought this up. I got a bunch of comments on the last video that I did about the Project Dragonfly. There was some version of that, right? Like, this is stupid. These technologies are too complicated. Who would ever do this? This is a waste of time. You know, and then some were more helpful and suggestive, like your comment. Well, just like, let's build a bunch of big, powerful telescopes. The reality is, let's do both, right? Let's build big, powerful telescopes, and let's develop better techniques for exploring both the solar system and eventually going to another star system. Now, it's not going to happen in a very short period of time, but that's why you can write things down on paper, and that doesn't mean that you have to commit yourself to actually building these things in real life. You are just writing it down. You are thinking. You are throwing ideas back and forth with people. You're taking the latest technologies and you are incorporating them into this idea of what would be a practical way to be able to send a probe to Alpha Centauri. And I think, you know, there was a tact that I should have taken in that video that I really didn't do, and I wish I had, and so I'll try to do a bit of it right now. It's starting to rain. Which is that I wish, like everyone wants to go to Alpha Centauri. Everyone wants to go to see what these other stars are like. And I totally get that, right? We are in this galaxy of 100 to 400 million other stars, and we can only see really what's going on in our own solar system up close. Sorry, 100 to 400 billion stars. Anyway, where's a million? Anyway, billion. We want to see what those other places look like up close, and yet we can't. So, how do we do this, right? How will we be able to get that close-up look? The reality is that it is going to be incredibly, incredibly difficult. And the best, I mean, I think the Project Dragonfly is like the best thought-through idea that I've seen so far. One that works with technology that we may have in the next 100 years, that sends a spacecraft within 100 years to get to Alpha Centauri, which is the closest star. The point is, it is at the very limit of what we can even possibly imagine. And we are too impatient, and we don't have the technology to be able to do that. And so we need to be comfortable. We need to be fine with the idea that we're going to be living here in the solar system for a very long time. But our technology will get better, and eventually what seemed like science fiction, what seemed like really out there ideas will start to become more and more concrete. We'll practice them in reality, and eventually some future group of engineers will put together those ideas and make something that can actually practically send a spacecraft to Alpha Centauri. There's nothing that breaks the laws of physics. You just have to be patient. And I think it's also fine to work on a project that won't happen in our own lifetimes, right? Like, there have been plenty of achievements that humanity has done. It's something very noble in this, to begin an important project that you won't see the end of, but future generations will. It's the opposite of us destroying the environment. Instead of us causing global warming, making the oceans filled with plastic, making life harder for future generations, why don't we start working on things that make life easier and more fun and more enjoyable for future generations? I think there's something great about that, and I think we should do it. All right, well, those are all the questions and comments for this week. Thanks, everyone, for sending them in. I love it. As always, wherever you are, anywhere on my channel, if a question pops into your brain, just write it out, and I will gather them up, and I will answer them here. I'll see you next week.